Alright, so in the front of this new book, Unit 6 here, Introduction into Quadratic Functions, should talk a little bit about what a quadratic function is. Before we do that, an absolute value function, do you remember what shape that meant? Whenever you did an absolute value, made a V shape, right? So this is going to be very similar. Anybody know what a quadratic makes? It's not a V, but it's similar. A U shape, right? A U shape is going to be more curved. So if you look at Unit 6 here, Introduction into Quadratic Functions, looking at the change, actual formulas of it, working with it, graphs. So this is pretty well all on quadratic functions. And then Unit 7 you'll see is also on quadratic. So basically the rest of the year we are going to be covering a lot on the quadratic formula, again, getting you ready for next year. That's going to be a common topic. So we have graphed a lot with lines, exponentials last time. We've done absolute value. Now we're going to roll into quadratics as well. So go ahead and go to page 6 and see if you can answer the first question. I'll give you about a minute or so. Just looking at those three tables. What's one thing you notice? What is one thing you wonder? So please answer both of those and be ready to share. Again, I'll give you a minute to take a peek at those. Maybe you don't need a full minute. Anybody tell me what's one thing you notice?
Third one's the one that goes in negative.
Third one's the only one that has a negative. Okay, that'd be fine.
The second table is doubling for every single x.
The second one is doubling. So 3 times 2, you mean? 6 times 2 times 2 times 2.
And the first one is plus 5.
First one's adding 5, linear.
The last one isn't.
Yeah, what's the pattern on the last one? That's one thing to wonder. What's going on there?
There's no code.
Other thing you notice, you could say 1 through 5 for the x values is listed on all of them. The inputs are the same for all 3 of them. Again, the only way you can get that wrong is to not answer. Question number 2, Jordan, would you read that, please?
No one has 50 meters fencing to completely enclosed rectangular garden in the backyard. Draw some possible diagrams of Noah's garden. Label the length and width of each rectangle.
All right, so let's draw 3 here. 3 different gardens. And let's use all 50 feet of fence. Meters, thank you. Anybody give me one?
25, 20. Like 20 on the long sides and 5 on the short sides.
That adds up to 50. That would be fine. Let's do 2 other ones.
And
10 and
on
15.
10 and 15?
Yeah.
How would you go it?
Because I wanted you to catch it. Another one? 24 and 1. Again, we are just looking for the perimeter to all equal 50. Only 3 possibilities? Or are there others?
Many.
Many others, right? Many others. So now number 2 says, find the length and width of such a rectangle that would produce the largest possible area. So I'm going to make a little chart here. Length, width, area. So I'm going to write down the ones that we did. First one we drew was 20 and 5. What was the area? If it's 20 and 5, it'd be 100, right? 20 times 5. Next one we said was 15 and 10.
150.
That's 150. And then we did 24 and 1. So it wants me to figure out how to get the biggest area. Right now it's this guy, but there might be ones bigger than that. So can anybody give me one that's bigger than 150?
Thirteen
13 and
and 12.
12?
Yeah.
What's 13 times 12?
156.
There's actually one that's bigger than that.
Was it 12.5? It's a square.
What is that, 156 point something?
5.
So hopefully you saw a pattern there, that the closer those two numbers got to each other, the bigger the area. And the closest you can get is 12 and a half and 12 and a half. That is a square, exact same number. You cannot get an area bigger than that. Question number 1 for part 3. Samira, would you take that one, please?
Plots and values for length and area of the garden on coordinate plans. What do you notice about the plotted dot?
All right, so let's plot the ones that we just have in the chart above. Notice you are plotting length and area. So the first chart is my X, the second one is my Y. So 20 and 100, 15 and 150, 24 and 24, 13 and 156, 12 and a half and 12 and a half. Now, kind of hard to see exactly what this shape is doing. We have a lot of large length. What if we would switch it? And what if I said the length was 5? The width would be 20 and the area would still be the same, right? So if I plot 5 and go up to 100, notice in the same location as this, just switching the area, length and width around. So the other one would be 10, 15, and 150. So 10 and up to 150. 1, 24, and 24. 12, 13, and 156 again. And what kind of shape? It says, what do you notice about the plotted points?
It's like
Go up
a
to
triangle.
Yeah, kind of a triangle. Now here is not a V-shaped, right? It's not a absolute value.
It's kind of like a bubble triangle.
But if you were to connect them, you would have our first glimpse of a U-shaped, a quadratic. Now, when you're plotting them with dots, It's not just a connection, it's kind of a nice flowing line. So what kind of shape is that? What's that called?
Quadratic.
Okay, it's a quadratic equation, but the shape itself has a name. Starts with a P. Quadratic has a special name, starts with a P. It's called a parabola. Parabola. The U-shaped has a special name, just like the V-shaped is called an absolute value. This is called a quadratic or a parabola. Quadratic, just for future reference, is always going to have something squared on it. Okay, so hopefully you notice here it goes up, comes down, same directions on each. This top part has a special name, that would be our vertex, peak of our graph. Question number 3. The points 366 and 2266 each represent the length and area of the garden. Plot these two on the coordinate plane if you haven't done so already. So 366, 2266. What do these mean in this situation? So remember, we are plotting the length and the area. So the 3 represents the length. 66 represents the area, so what's the width? 22. And the other one's just switched. 22 is the length, area is 66. Question number 4, could 125 represent the length and area?
Yeah. Wait, no.
So can you give me a width? 25, now does that work?
No,
Why not?
because it doesn't meet the requirements of 50 meters for a perimeter.
Yeah, that does not equal 50, that would be 52, so no. That does not work. Are you ready? Question number 1. Amy, would you read it, please?
What happens to an area when you try to interchange the length and width? For example, compare the areas of a rectangle length 11 meters and width 14 meters with a rectangle of length 14 meters and width 11 meters.
Okay, what happens to the area?
Stays the same.
Should be the same. Somebody's got Desmos open. What is 11 times 14? 154? So the order you multiply does not matter. And what patterns would you notice if you were to plot more length and width pairs on the graph? So if we were to put more on here, more dots, how would you describe the pattern?
Well, it should still be at the same length line.
Wouldn't it be just like across from each other?
Yeah, they always should be across from each other because you're just flipping it and the area stays the same. So basically, if you have one, you should always be able to get the other. Okay, so if I would just choose to add another one here, let's say the width is 8. What would be the length? Remember, the perimeter has to equal 50. 17. 8 plus 17 is 25. 8 plus 17 is 25. That's how I get to 50. What's the area? 17 times 8. So if I were to plot those, length of 8, go up 136, it should fall right in line. And now if I switch it and make the length 17, it should be directly across from the one I just put on there. Same distance from the vertex, same height, directly across from each other. Okay, so hopefully you can begin to see some of this, and you do have to expand the graph a little bit further. All right, if you were to just look at this part, that would look like a linear, things we've already done. If you see a shape like this, you might have to expand it out a little bit. This you can tell is going to be a U-shaped, a quadratic. Okay, something squared. Go ahead and take a peek at your first assignment then. Starting on page 10. First 4 are from this lesson. I don't think those will give us any trouble. If it does say explain, be sure you do so. Question number 4 is multiple choice. One of those is true. It says which statement. That is multiple choice. These are from last unit, from unit 5. Remember, if it loses 1/5 of its value, what that means of how much it retains for number 6 there. Question number 7, it does say use graphing technology to help you out there. So I would plot this in Desmos. X, Y, look at the scatter plot. Make sure you push that little magnifying glass thing, that'll zoom in perfectly for you. And then answer the questions accordingly. And question number 8, referring to the R value, easiest one on there today. So 1 through 8 for tomorrow. Or get a lot of time to work today. We have no warm-up, we have no homework to check, so should have plenty of time. 1 through 8 for tomorrow, please.